First of all, thank you so much for everybody that is joined us today, that registered for our webinar. We've been working really hard on this, and we're so excited to kind of give you guys a view into the world that is AI, large language models, and sort of this really up and coming. Well, we'll kind of learn it's not so much up and coming, but it's really has seen a resurgence in the past year, and it's all over the news. We're hearing about it all the time, so we're very excited to kind of kick off and show you guys what we got. So first of all, I just want to introduce our team. We have Mr. Zach Phillips-Gary. He is a senior site reliability engineer here at Jahnel Group. And we have Alec Herring, Jahnel Group's resident AI expert, boy genius. He's been working here since he was 15. And trust me, he's older than 15 now. I promise you that, even though it might not look like it. And then we have myself, Joshua Whalen. I'm our strategic marketing coordinator here at Jahnel Group. So just to give you guys a sort of an overview, Jahnel Group, we're a custom software development firm here in upstate New York. You know, we're an advanced AWS tier partner. So we do a lot of work within the cloud space, and we're starting to really dip our toes into that AI space as well. So we're excited to kind of show off what we got for you here. To go over a quick agenda, so we'll kind of give you everybody a overview. What is AI, right? We're hearing about it all the time. OpenAI making a lot of headlines recently. So we'll give you a general overview of the industry and what it is and how we got here. And then what we'll start doing is kind of going through more of a deep dive, right? So we'll take a peek behind the curtains, show you some architecture, some code base. I know Alec is going to go into some product development work that we've been doing here at Jahnel Group. And then I actually will close this out with a little bit of talk about AI and how we can use it in our business lives, right? You know, I don't write the code here at Jahnel Group. I leave it to these guys. But what I can do is I can take the work that these guys give me and do some amazing things with it. And we'll finish up with a nice Q&A. So if you do have a question during the webinar, you can put it right into the chat, or there's also a Q&A application as well that you can put your questions into. I'll be collecting them, and we'll have some time at the end where I'll be able to read those off, and Alec and ZPG will be able to answer those for you. So without further ado, ZPG, take us away, my friend.
Hey everybody, so you know, we've all heard a lot about AI in the news. Some of us may have played around with it a bit, but you know, what do we mean by AI? You hear AI, ML, those are probably two of the biggest buzzwords I think in the tech space in the past 20 years, besides maybe crypto. So when we're talking about AI, it's a pretty general term about any machine-based system that we can give a set of objectives and it makes predictions, recommendations. It can make inferences either about a real environment or a virtual environment. So this is everything from, you know, machines that do forecasting for climate modeling, can use artificial intelligence to robots. So today we're going to be focusing on a particular subset of artificial intelligence that's really become very exciting in the past few years, and that's called large language models. So what are large language models? Well, large language models are based on deep learning, which is a subset of machine learning that uses artificial neural networks to basically learn and extract patterns from large amounts of data. We'll get to sort of the importance of that data a little bit more later on. Really where we've seen it extremely useful is in the image and speech recognition and generation spaces, and specifically within deep learning, which is a very broad field. Large language models really leverage transformers, which are a specific architecture for deep learning that was developed in 2017. Basically, it uses a self-attention mechanism to basically generate text, perform translation, and a lot of other tasks. So basically, these models give a computer program the capability to understand and generate language. This can be natural language, like how I'm talking to you now, computer language, and it can not only process English, but pretty much any human language we have out there. So really very versatile and exciting technology. So you may think, okay, I've been hearing about this a lot. LLMs are a pretty new innovation. They really have their roots back in the late 60s with ELIZA. ELIZA is a very simple, very primitive by today technology. Really use kind of a lot of tricks to kind of emulate like a therapist kind of chatbot, but it really was the first real chatbot that could really talk like a human. Um, then in the 90s and early 2000s, we have a lot of developments along the way. We see neural networks come along. Google Brain does a lot of exciting stuff with AlphaGo, using these architectures. But really, the moment that really brought LLMs into the spotlight is the introduction of the transformer architecture, with this paper in 2017, offered by a bunch of folks from Google called Attention is All You Need. That really laid the stage for 2020 OpenAI to release GPT-3. This was really the first model with transformative uh, abilities within the space of large language models, where it could generate text, perform very impressive machine translation. And from that, we started to see products spawn. OpenAI used GPT-3 to release ChatGPT, which was really one of the first consumer-friendly applications of this technology that you could use. And from that, today we have GPT-4, the latest iteration of OpenAI's LLM flagship model, as well as a lot of other really interesting products out there, like the Llama, which is a offering that's open source, supported by Meta. So you've been hearing a lot about these technologies in the news. Everybody's talking, is AI going to steal my job? Will there be programmers in 10 years? But a lot of you may have been in the industry for a while and may have heard of this phenomenon called AI winter. So, in the 80s and early 90s, there was a lot of excitement as well around AI, and that kind of fizzled out. So you might be a little bit jaded if you've gone through one of these boom bust cycles of AI and be like, is this stuff just a lot of hype, or is it something that I really need to be worried about? We don't think that AI is going to come and get rid of everybody's jobs. We think that, LLMs and these recent developments in AI are really going to usher in a new exciting era with a lot of technology that we as technologists and business people can utilize to transform and empower our businesses and our lives. So the big players right now in the AI space are right here. You can see a lot of these are familiar names for you. You've got Anthropic, which is um, a really interesting new company we'll talk a little bit more about later. It's coming into the space. And then OpenAI, they're kind of the Kleenex, if you could say, of the AI space. They're kind of synonymous with LLMs, with ChatGPT in their flagship product. There's a lot of money going into AI right now. So really the leader right now of the pack is OpenAI in a lot of ways. They've had some leadership changes, a lot of kind of drama going on behind the scenes, but in spite of that, ChatGPT really is the product. When you think of LLMs, it's kind of synonymous with LLMs AI in this day and age. It's backed by the GPT 3.5 and GPT 4 models under the hood, and it's bringing in approximately $80 million in monthly revenue. Really, this spurred a lot of investment and excitement about the space. So you see a lot of other major tech companies are also trying to get in this space. Amazon has released a ton of AI offerings. If you've seen reInvent and a lot of their recent announcements, one of the other big ones is that they are going to be investing about $4 billion in Anthropic, which creates a product called Claude AI, which is sort of one of the most exciting newcomers to come out of this LLM revolution. There's a huge market, available here with AI and LLMs. Generative AI and LLMs are expected to become a $1.3 billion market by 2032, which feels a lot closer. Might feel like the future. You hear that kind of date in sci-fi, but it's around the corner. We're just seeing a huge amount of growth in this space with all of the new technologies and all of the applications for this in the world today. So one of those really exciting new innovations, you know, a lot of you are familiar with sort of the chatbot model for that, but very recently these models developed viable multimodality. So not only can you create a poem or generate some Python code for you, but you can give them a photo and they're able to comprehend that and generate a recipe, as you can see here, or identify the people, places, things in the image, and infer information about it. They can also integrate with other models to create images, which we'll be seeing a little bit later. So you might wonder how that multimodality works if it's text-based. So this animation here kind of shows you the image is run through an encoder, which is then passed into the LLM, as this animation here shows. And then a prompt is applied by the user, and the LLM creates output based on that. And we're going to kind of zoom into that black box, that LLM square, a little bit more and understand what really is happening there in a few minutes here. So I'm going to turn it over here to Alec, who's going to kind of zoom into that box, show us it's not magic, and help us kind of understand what these things actually do and how they work.
Yeah, okay. Thanks, Zach. So as Zach said, I'm going to try and give you a little peek behind the curtains, zoom in a little bit, and hopefully by the end of this, you can see it's not magic. It's not something from a different world. And it's not something you should be afraid of pushing the buttons on, so to speak. Because at the end of the day, that's the worst thing that you can do with a new technology. It will just lead to you falling behind. So the first thing to know is that LLMs think with tokens. So tokens are basically quantitative representations of chunks of text. And the reason why we need to do this tokenization process is because at the very root of these LLMs, it's using something called a neural network, which you can just imagine as a very complex math problem. And as you probably know, you can't perform math on a word, maybe a variable like X or Y, but not on an entire word. So during the tokenization process, we'd convert something like this chunk of text into this list of numbers here. And these tokens are the most common strings in the training data. And GPT-3 and 4 have a total of 100,000 tokens. And if we take a look at how something like Jahnel Group is tokenized, you can see Jahnel is broken up into 3 separate tokens, while Group is 1 token. And the reason for this is because Jahnel, relatively speaking, isn't a very, very common word found around the internet, while Group is. And then if we take a look at something like this, 64 equal signs, despite it being significantly longer than something like Jahnel Group, it's actually compressed into 1 single token. And again, the reason for this is that it's fairly common in its training data, not necessarily just randomly on the internet, but in code comments. And then lastly, blink twice if you're conscious is broken up into these tokens. Next thing to know is that LLMs think 1 token at a time. So just like your brain is doing right now when you read the phrase, "It's raining cats and," your brain is probably predicting dogs comes next. That's exactly what these LLMs are trained to do. Just be very good at predicting what the next token is. And if we take a look at a real life example, this is from GPT-3. If we start with the quick brown fox, we can see that GPT-3 predicts that jumps has a 32% likelihood of being the next word. And then over 99% the lazy dog. And just like that, we have a complete sentence. So how are these things trained? So first, we gather a bunch of data, an insane amount of data in the form of text. And then we go into the pre-training phase, followed by fine-tuning phase. And then lastly, human feedback or reinforcement learning from human feedback. So during the pre-training phase, the goal is to capture the underlying semantic knowledge, patterns, or structure of the text. So we first start with that large amount of text, right? And then we sample a small chunk of that text, and then we feed it through the transformer architecture that Zach commented on earlier. And basically, during this step, it's just trying to get very, very good at predicting the next word. And when it sees millions and millions of snippets of text, and it's constantly tweaking the internal model to get it have a higher likelihood of predicting that next word, it gets very, very good at this. And then at the end of this step, we are left with a model that's very good at predicting the next word. But predicting the next word isn't necessarily the most ideal solution when we want to have a chat-based application like ChatGPT. So how do we align the model to have a back and forth conversation like you see in a chat-based application? And that's where the fine-tuning step comes in. And you can imagine during the pre-training phase, we're left with like a ship that has no direction. It doesn't know where to go. And during the fine-tuning stage, we're kind of aligning this ship and giving it a very specific direction. And we start out with a prompt. Then we have a labeler, typically a human, write out a response, like an ideal response for this prompt. And then we feed these two sets of data into the model, and we perform something called back propagation on it, which calculates how close the predicted response was from the desired response that was written by the human. And the difference between those two responses are calculated and used to tweak the numbers inside of that super complex algorithm I was talking about earlier. But this in and of itself is very time consuming, very laborious, and requires a lot of people. So how do we scale this up to a massive scale? What if we could have an AI help train this AI? And that's where reinforcement learning from human feedback comes in. So during this step, we start with a prompt and followed by various potential responses to this prompt. A human then ranks these responses from best to worst responses. And then we train something called a reward model to get very good at predicting what a human would rank a good response and what a human would rank a bad response. And then with this reward model in our hands, we can then go to the next step where we start with a prompt again, predict or generate an output, and then feed that into our new reward model, which again predicts how good of a response it was. And then we can use that reward rating to feed it back into the model, which then tries to tweak the numbers inside of it to have a higher likelihood of predicting a better response next time. And when we iterate over this millions of times, we get very, very good at predicting very good responses that a human would rate as high quality. Okay, so now with that fundamental knowledge, I'm going to now pass the torch over to Zach again to talk about some limitations.
Thanks, Alec. This has been super interesting. So now that we've all kind of demystified AI a little bit, let's talk, and we've seen a little bit about what it can do. Let's talk a little bit about where we have to be careful about using it. So I think we mentioned this a little bit earlier before. Hallucinations are a huge problem for AI. So you might think, wow, it can generate poetry. It can even create a recipe for my breakfast based on a photo that I pulled off the internet. You know, a little arithmetic should be no problem for it. So you might think that. You might put something like this, use it as your calculator. And if you're like me and, you know, you're not a huge mental calculator, you might say like, hey, this looks pretty plausible. I think it's got it. Yeah. But as you can see here, it's actually off by what could be a pretty significant amount if you're dealing with financial sums or rocket fuel or any kind of sensitive application like that. So as you can see, AIs just generate something that's similar to the expected output. It's not guaranteed to be perfect. It doesn't know what is actually functional in the sphere of mathematics. It can generate code with errors in it. It can create incredibly fake events if you ask it about history, or fake functions and methods if you're a programmer and you ask it to generate some code for you. So you always need to verify. You can't blindly trust the output of an LLM. Another major concern when you're building an application of AI is cost. As you can see from the figures here, running these models using a closed source system like OpenAI's GPT can get quite expensive. And you may also sometimes see high costs in terms of infrastructure. If you are running a self-hosted model yourself, you need a lot of GPUs and horsepower to run those models and be able to get effective inference from them. So no matter how you're running your models, computational cost and the financial costs associated with that are definitely something you have to be aware of. You'll see here as well that the cost varies quite a bit, even based on the same model when we're dealing with context. Now, what is context in the context of AI? As you can see here, LLMs have a context limit. There's only so much information input that you can throw at them at a single time. You can think about it as kind of like desk space, or if you're a more technical person, RAM a little bit. There's only so much data you can provide to them, and providing that data is one of the ways you get better results. So models with larger context limits, you can often, but not always, get better results from, because you can provide more information in your prompt. So you need to be aware of that and find the best model for what you're doing, and sometimes you have to make some difficult trade-offs based on those context limits and the associated computational costs with them. Another big concern is knowledge gaps. So in addition to hallucination, AI models are reliant upon the data they were trained on, so they only have very limited ability to infer beyond what's explicitly written in the data that they're trained on. They don't have the ability to know what's happening right now. So the OpenAI models are a great example of this knowledge gap. They have cutoffs, so they don't know stuff beyond certain epochs, which can be, as recently as a few months ago or a couple of years ago, depending on the model. There are ways, as we'll talk about, to, connect them to the internet to get some data, but just as standalone LLMs, they do have sort of a knowledge limit, a certain time that they won't know things that are happening right now. So that can be a limitation sometimes, depending on the type of application you're using. And then because they are heavily limited based on the data they're trained on, they aren't going to know about your company's, internal code names for things unless you train them on that data, which we'll talk a little bit about more later. They're not going to know, who's your coworker who sits down the hall. So you do have those limits too. They, again, aren't magic, so they're only as good as the data you feed in. But we're software engineers, so problem solving is our specialty, and luckily there are a lot of tactics and tricks you can use to enable LLMs to work around these limitations and provide meaningful results for your business. So I'm going to turn it over to Alec, who's going to give us a little view into some of these tips and tricks and how we can work around these limitations.
Yeah, so thanks, Zach. As Zach said, software engineering is about solving problems. So let's discuss some of the ways to solve or at least mitigate these problems. So first, as many of you have probably heard many times, prompt engineering is one very useful way to improve the output of these LLMs. So something as simple as just having it think step by step rather than just giving you the answer right away can drastically improve its accuracy. And this is kind of like, you can think like yourself. If it's not a problem that you've ever encountered before, breaking the problem down and into smaller chunks is very, very helpful. And then it's the exact same way for these LLMs. Second is through fine tuning. And the powerful thing about fine tuning is that you teach by example rather than through instructions. And you can kind of think of this as the difference between giving someone, like a person, a list of instructions on how they should behave, versus like opening up their brain and using some sort of sci-fi technology to modify their physical brain and change how they think. So that has various different benefits. One being cost. So since you're not having to supply the model with like a very long list of all of the different instructions and behaviors you want it to follow, it's already knows all of that. So it does, you don't need to supply all of that every single time you query the LLM. And then second is lower latency. Since the model is having to process less each time, it's just inherently faster. And then lastly, giving it access to external resources. So as you'd expect, if you just asked a model like GPT-4 a question about like some internal company event, it's just going to respond saying it doesn't know, or even worse, it's going to make up some fact. Then how are we able to achieve something like this, where I ask AI who won the mugshot challenge, which is an internal company event at Jahnel Group, and it responds saying who the winner was last year. We do that with an architecture kind of like this. So this is a zoomed out view of the architecture of a internal tool we built at Jahnel Group called IntelliJG. And at the very surface, what you're actually interacting with is a language model, more specifically GPT-4. But then behind the scenes, we have something called an embedding model, embeddings, and a vector database. Some new words. So what is an embedding model? So an embedding model, very simply, is an AI model that sole job is to take a snippet of text and convert it into something called an embedding. Well, what is an embedding? An embedding is like a list of numbers or vector that quantitatively represents the semantic meaning of the input text. So regardless of whether it's one word or an entire chapter of a book, the response is always going to be the same amount of numbers. And that's because instead of it representing the actual content, it's representing the meaning of that content. And the value of this is we're able to do something like this, where if we plot it in a 3D space, you can see semantically similar things, such as Jahnel Group and a software development company are very closely tied. And we can take advantage of this in conjunction with a vector database whose job is to figure out what vectors are closely related. And so you can query the vector database with a vector, and then it will respond to you with the closest related vectors. So let's take a look at a simple example of all of these things kind of glued together to see how like an application like this is actually developed. So we start out with two separate functions. We don't have to get into the inner workings of each function, just need to know about the two functions, one called query GPT and then one called parse response. The names are and they do exactly what the names suggest. And we can test out the query GPT function by passing in a system message, which is kind of like the instructions for the model. So the system message being, you are a funny, sarcastic assistant who loves dad jokes, and then have the user input be, I'm hungry, what should I eat? And we can see the response is a very dad joke-esque response. Well, if you're hungry, maybe you should check the fridge. How about something like Italian? Or is that too much to possibly handle? But what if we want to ask it something like, what's the dress code policy? As you'd expect, and as you saw earlier, it's just going to respond saying that it doesn't have access to anything like that. So let's fix that. We can take advantage of some very powerful functionality in the OpenAI ecosystem called tools, which you can kind of think of as pseudo functions that are passed to the model, and the model knows that in situations where it deems fit, it can, instead of responding with an answer, it can instead call that function to gather more information. And this is where you see, like in ChatGPT, if any of you have used the new GPT-4 iteration, where it will call out to the internet. This is the exact functionality they're using behind the scenes. It determines it needs to gather information from the internet, so it calls their internal browser function. So now with this added tool, if we ask it the question again, we can see instead of responding saying it can't help us, it will instead respond with a function call searching for the dress code policy. And we can add some logic to handle such a response. And we can see now it knows it needs to search the database for the dress code policy. What database, though? We don't have one yet. That's where ChromaDB comes in. It's an open source vector database. You can use any vector database, such as Pinecone, which is a very popular one. But at the end of the day, all of these vector databases are doing the exact same thing. They're performing cosine similarity search on the vectors, which is just like a complex math problem. So we'll create a collection called Jahnel Group Docs. But if we want to add anything into the collection, it needs to be in the form of a vector or an embedding. So let's add some functionality to convert our text into an embedding. That's where OpenAI's text embedding ADA2 model comes in. And we wrap the logic in a vectorized function, which takes in some text as input and then responds with the resulting embedding. And as we can see here, if I try to vectorize something like Jahnel Group's core values, it responds with a 1500 number long embedding. So now we can iterate through any internal data we want to add into the vector database and test it out. So if we search for something like the dress code, it responds with the dress code, as you'd expect. But what if we search for something that doesn't have an exact word match, such as battle? We don't have anything in the database with the word battle in it. But if we search battle, we can see it responds with some information about an internal company event at Jahnel Group called War Week. And that's because word and battle are semantically similar. And if we search something like COO, it understands COO and Chief Operating Officer are semantically similar. And that's why it responds with information about the COO, Jason Jahnel at Jahnel Group. So now if we glue all of this logic together and modify the query GPT function to have this new logic, we get a result like this, where I can search something like that's some technical difficulties. Oh, there we go. Search something like who is the COO, and it will respond with a query to the database, search the database for it, and then respond saying it's Jason Jahnel. And I can ask it something like, what's the mugshot challenge? And it will respond with a query to the database, searching mugshot challenge. And now as we speak, it is writing a response with the newly supplied information. And you can see it responded correctly. All right, so now with that demo, I'm going to now pass the torch over to Josh to talk about LLMs and business.
Whew. I don't know about you guys, but I was a little lost there for a second, being a non-coder myself. These guys are just absolute geniuses and can make these absolute monster of machines and technologies work. But what they can do for me is they can actually make my life easier during a day-to-day business setting. So I wanted to kind of just go over, if you are not a technical person on this call, and you are just maybe as lost as me, how we can actually just use these LLMs in our everyday life, right? In our everyday business life. So I'm just going to run over some examples of how businesses are already doing that. So one is customer service, right? We can have automated responses. AI chatbots are becoming a huge market. We're getting constant requests at Jahnel Group to make AI chatbots for certain companies. That's going to be a really growing market over the next few years. We have translation services. You know, we are in a global economy. We work a lot of our business is done internationally now. So we have language barriers between business partners and business associates. And what AI can do is literally, it's a language model, right? So it can cut down those language barriers for us. Also content creation. Myself, the marketing guy, I love ChatGPT. I love using AI to help myself with this content. Either help me out with, I can use it for like proofreading. I can have it actually like, put some information in and have it do a really great social media post. Maybe it helps me write an email to a client. Just kind of gets me over that hump of like, hey, here's what I want to say. I can sometimes just prompt it with, make this sound better, So other ways that we can sort of broaden the horizon with our everyday business lives with these LLMs, is brainstorming and strategy development. So, I'm a creative guy. I love to brainstorm, come up with awesome ideas, but even myself, I can sometimes get into a sort of a creative rut. You know what I mean? I can get stuck doing the same thing over and over. What these LLMs have been able to help me do is sort of get outside of my comfort zone, and push the boundaries of what I would usually think on my own. Maybe it throws out an idea and it's so obvious to me that I'm like, how did I not think of that myself? Or it throws out something that's so out of left field that I'm like, what the hell were you thinking, ChatGPT? But this is a great idea and I think I'm going to do it. It's also good for summarization and data analysis. An app that we use sometimes with internal calls is Firefly AI. And that just helps basically summarize meeting notes for us. It allows us to see, who is talking, what they said, key takeaways, action items, stuff like that. So there's AI for that. But what about building our own, right? We already saw with IntelliJG, this is an internal Q&A and knowledge sharing app that we've built at Jahnel Group. It is available for sale, just saying, if you want to talk to me after, if your business is interested. And, I am part of the sales team, so what about sales, right? Like, can we use it can the sales team use tools like LLMs? And the answer is, of course, yes. Alec had created an amazing application for us called Sales Sherpa. So let's say I want to write an email to maybe a prospective client that I've done a little bit of research on. I can see that they like Star Wars, and I know that they love to run marathons. That's literally all I need to give to this app. And here's this amazing email that it writes out for us. May the force be with you as you tackle those marathons and bring that same unstoppable energy to your work. It's clear that you're always up for a challenge. And man, what an email. If you got that, I'd be super impressed myself. And that is a chat that is an LLM that we built in-house right here at Jahnel Group. That's an internal application that we were able to use from just connecting to APIs within ChatGPT and other AI sources. So, get past there. So, anyways, that was amazing. Thank you so much for everybody who joined us today. I hope you walked away with something new. Hope you can kind of think about, hey, how can I use AI in my own life, right? Whether it be business, whether it be personal. If you haven't used it yet, go to OpenAI, go to go use Claude, ChatGPT, any of these, Dolly for image creation. There's a ton of tools out there right now. And I think that, my challenge to each one of you on this call is, if you haven't yet, try it out, see what it can do. So we did have a couple questions during the call, and I want to get to those. So one of the questions was, and of course, yep, if you have more questions, please put them in here. We would love to get to them. So Alec and Zach, I'm gonna start prompting you guys with a couple. So maybe you can touch on how these massive AI players are truly monetizing this solution as the average user has free access. Alec, you want to go for that one?
Sorry, can you repeat it? You broke up.
Yep. Maybe can you touch on how these massive AI players are truly monetizing this solution as the average user has free access?
Yeah, so we'll just look at something like ChatGPT. So they have two separate business models, one being very similar to something like any free platform that is available online, such as Facebook or Google. You are their you're their product, not their customer. And you can see that by the fact that they are very clear about the fact that free users, anything that they're saying into ChatGPT is being used for training data. So all of that data is being collected, and data, as we know, is the new gold. So they're gaining very valuable information. And then the second part is through their enterprise offerings, and that's where their API comes in. And their API, they don't. You're no longer their product. They don't train on any of the data that's fed into their API, and instead you are paying them for to use those models. So they're banking on massive companies using their API, paying them, and whether that's through their API or with their partnership with Azure, where Microsoft is paying them, and also anyone who's using the self-hosted version of GPT-4 in Azure is also paying OpenAI.
We've got another question here. How are embeddings different from tokens?
Yeah, great question. So embeddings you can kind of think of as just a very direct link. So like the letter A might be associated with the token 1, and then something like cat is associated with the token 300, right? So it's a very clear one-to-one relationship, whereas tokens are numbers or vectors, embeddings are numbers that are generated from the inner logic of an embedding model. And these are numbers that are between 0 and 1, and they are not human readable in any way. They have no meaning to a person just looking at the numbers, as you could see on, if we go back to this slide, if we look at the numbers in the back, this is just from a few words, 1,500 different numbers, and those numbers are just generated by an internal model that like it has a meaning to it, but not to any human. Does that
All
make
right,
sense?
we got 2 more questions here. I know we're about a minute or 2 over, but I want to get to them. So the first is, are you familiar with Bubble? If yes, are you planning on using that tool in JG to build simple apps by managing APIs?
I am not familiar with Bubble. Zach?
I'm not either. So
Okay.
definitely interested in
I will
looking more to.
I will mark that down. We'll try to get to that. We'll try to get that answer to you after we do a tiny bit more research. And I got a last question here from Peter. How do you cope with all the news on AI daily? How do you filter for relevant info in your field?
Yeah, so there's a lot of
TBG,
signal to noise. Yeah, there's a lot of signal and noise out there. I kind of go old school, and I actually use RSS feeds. If you guys remember those from back in the day, to kind of get a summary of what's going on, and then I typically try to focus on AI information that is most relevant to the type of work and projects I'm doing. So, hacker news, specific subreddits that are focused on that niche. Those are kind of the areas within AI that I try to really focus my attention on, because the big developments are going to trickle down into those subfields when they become relevant to me. And that kind of helps you just stay focused on, what's important to me and my work, as opposed to getting lost in all of the open AI drama that's been going on around leadership changes and stuff like that.
Darren just put I was just about to say, Darren just put a great website in the chat for anybody that's interested in AI news.
And another thing I'd like to touch on is, especially in the beginning, like earlier this year, it probably seemed to many people that like AI is moving at some insane pace. Like every single day, there's a new AI company, a new AI product coming out. What I'd like to emphasize is that almost all of these new AI companies are using one of the main AI models behind the scenes. So GPT-4, Claude, something like that. So while there's new AI companies, the rate at which these models are being produced and released is significantly slower, just because of how long and how expensive it is to train these models. So at the end of the day, if you are overwhelmed with all of the AI news, just pay attention to what new models are coming out. And that's where the actual like advancements are coming from. So until a new, like more advanced model is released, you're not going to see some drastic change in capabilities. You might see little improvements, like giving it access to the internet or something like that. But its actual like internal abilities hasn't really changed.
So I think that's it. That's all the time we have for questions. So first of all, I just want to thank everybody who stuck around here till the end. This is an amazing opportunity to sort of show you guys our knowledge and what we've sort of been working here at JG. And we, again, like I said, I hope you've taken something from this today. I can reach out to everybody after in case you had any questions that I didn't get to. But once again, thank you so much. And hey, one last pitch here. If you ever have some custom software development needs, Jahnel Group in Schenectady can knock it out of the park for you. So we hope that we've sort of shown you some of our brains and bronze over here during this webinar. But once again, thank you so much, and have a great day. Have a great holiday, everybody.
Yeah, thanks,
Thank
guys.
you, everybody. Have a good holiday.